So in the previous class we have discussed about haloform test. Now in this class we will be learning about aldol condensation. So what is aldol condensation? Any idea? Aldol, see beta, aldol is a compound and condensation means combination of two compounds, right? So we will understand what is aldol, what is the meaning of aldol, and then we will understand how this compound is prepared by condensation method, right? So condensation method is nothing. Condensation means combination of two molecules, right? They condense and two molecules condense to form one molecule, right? So how this will happen? See, this when you see aldehyde and ketones, if I draw any aldehyde, this is the general form of aldehyde, right? If you see this aldehyde or if you see any ketone, you may find that this carbon, see, this is our alpha carbon, right? Right? Functional group. So if you see this carbon, you will find there is one or more than one alpha hydrogen atoms are there, correct? Correct, beta?
Yes, sir.
Hydrogen
Yes.
atoms are there. So if hydrogen atoms are there, then what happens? See, this reaction combines in this way. Let's suppose I have taken a compound like this. This is our ethanol, aldehyde, right? Ethanol. And let's suppose we are taking another ethanol, right? This is also ethanol, correct? Correct, beta. This is also ethanol also, right?
Yes, sir.
This is also ethanol. Now, this reaction undergoes in the presence of dilute sodium hydroxide. Now, what will happen? See, this is our main functional group, and the carbon which is just next to the functional group, that carbon is known as alpha carbon, correct? Correct.
Yes.
So all the hydrogens of this alpha carbon will be known as alpha hydrogen. So this is also alpha hydrogen, alpha hydrogen, alpha hydrogen, correct?
Yes, sir.
So what happens? Alpha hydrogen of this ethanol, this one, it gets combined with this oxygen, right?
Yes, sir.
How this will happen? Due to the electronegativity difference, right? Since oxygen is more electronegative, this will pull the shared pair of electron towards itself. Carbon will become slightly electropositive, right? Partial positive charge will be developed. You know, this carbon is more electronegative than the hydrogen. So hydrogen will be delta positive and carbon will be delta negative, correct? So beta,
Yes.
this hydrogen, this alpha hydrogen will combine with this oxygen of this carbonyl group, right? And this carbon and this carbon will combine with each other, right? When this bond will break, this hydrogen will combine to this oxygen and this carbon and carbon will get bonded. So this is known as condensation, right? So you see beta, in this we need no raw material. Only raw material is aldehyde and this is dilute alkyl, sodium hydroxide, right beta? So what is happening in this reaction? I'm going to completely write this reaction. This O will become OH after combining with this hydrogen, alpha hydrogen. Carbon will get bonded with each other, right? And this molecule will remain as it is, right? So what do you see? What is the special in this compound?
Sir, we are getting a higher
See,
alkane or aldehyde.
yes. See beta, this is our main functional group. If you'll see the periodic table, if there are two functional group in a compound, right? Hydroxyl group is there plus carbonyl group is there. So if you'll see the periodic table, we give priority to carbonyl group. So our parent name of this compound will be aldehyde, not hydroxyl, right? So we will consider this CHO, C double bond OH, this will be considered as a main functional group. So if this is a main functional group, then the carbon just adjacent to this main functional group will be treated as alpha carbon, correct? So if this is a alpha carbon, then this should be beta carbon, correct? Okay. So you see the name of this compound is nothing but beta hydroxy. How many carbons are there? Meth, eth, prop, bute. Butanol. Correct? Beta hydroxy butanol. And the common name of this compound is aldol. Now have you understood why this compound is known as aldol? Because this compound contains aldehyde also and alcohol also, OL. That is why combination of these compounds, actually this is self-condensation reaction, beta. Aldol condensation is nothing but this is self-condensation reaction. This is self-condensation reaction. Understood? This is a self-condensation reaction. So what is happening in aldol condensation? Let's suppose if you are asked in the exam, in the board exam, to write the theory about this. So how you will frame this theory? You will frame theory like this. Let's suppose you have taken an aldehyde. So what will happen? All the aldehydes and ketone contains at least one alpha hydrogen. Correct? Why I am telling at least one alpha hydrogen? Because see, if you are taking an aldehyde or let's suppose this alkyl group, in place of R you are taking H. Correct? Then also what you will see? You will see this compound. So okay, now tell me, this will go self-condensation or not? According to this concept, whatever we have understood, formaldehyde will go self-condensation or not? Let's suppose we have taken this compound. This is formaldehyde, or you can write in this way, HCHO. Does it have any alpha carbon?
No, sir.
Right? Does it have
No, sir.
alpha hydrogen? No. So this formaldehyde will not go aldol condensation. Only molecule bigger than, so there should be at least one alpha hydrogen. So for having at least one alpha hydrogen, there should be one alpha carbon. So if there is one alpha carbon, then definitely there will be one alpha hydrogen, and then that alpha hydrogen will get combined to the oxygen of the same molecule, right, of the same form, and then we will get a compound, special compound, which is known as beta hydroxy type of compound, beta hydroxy aldehydes. So in general, can I write this is nothing but this is beta hydroxy aldehyde? In place of butanol, can I write in this way beta? Understood? So this compound is known as aldol, and this is very important. Understood? This is very important. Now let us move to the next concept. Let's suppose we have the same molecule, that is beta hydroxy butanol. So how many carbons are there? 1, 2, 3, 4 carbons were there. There should be one oxygen here, one hydrogen here, such that this becomes CHO, right? So since this is my alpha carbon, this is my beta carbon. So on beta carbon there will be one hydroxyl group. In order to balance valency of the carbon, I should place 1H here, and again how much hydrogen? There should be one hydrogen here and one hydrogen should be here in order to maintain the valency of the carbon, right? Now what will happen if you will add a dilute HCl in this compound, and if you will gradually heat, what will happen? Any idea?
Sir, it will break down to ethanol and ethanol, like two products of ethanol.
Okay, let's see what will
basically
happen.
reverse of condensation.
Okay, let's see what will happen. See beta, like what will happen when you will heat this compound in the presence of dilute HCl, slightly acidic medium, and you will warm this compound, and what will happen? This OH group will combine with hydrogen group, and what will happen? There will be a loss of water. What will happen? When you will heat this, there will be a loss of water. So what will happen? You see, now there will be a double bond. This is CHO, right? So if you will write this compound in this way, CH double bond CH double bond CH. Now can you name this compound? Plus water molecule, or water molecule has already lost in this reaction. How you will do the nomenclature? This we will give less number to this compound, 2, 3, 4. Then what is the name? Butane. What is the name? But 2 in null. This is the correct name. Right. Now that is important note. So what is the important note? That aldol condensation is undergone by only those aldehydes and ketones which possesses at least one alpha hydrogen. Right? Right, beta? So
Yes.
there should be at least one alpha hydrogen. Otherwise, aldol condensation will not be positive, will not be possible. So I'm giving you example. I'm making a compound. What is the name of this compound? This is benzaldehyde. Correct, but and I'm drawing a ketone, aromatic ketone. Or I'm drawing compound like this. This is a benzaldehyde. So will it go aldol condensation? Does it have any alpha hydrogen?
Yes, sir, it does.
So where you are finding this alpha hydrogen?
So, the carbon attached to the aldehyde part of the compound. So, like top one.
Beta, this will not go aldol condensation. Why? Because it does not have alpha hydrogen. Why it is not having alpha hydrogen? If you will draw the structure, you will see this carbon, beta, this carbon. This will not go aldol condensation, right?
Okay.
Got it? You can draw a structure like in this way. Instead of ring, you can express this in form of single bond and double bond. Let's say I'm drawing like this way, alternate double bond, single bond structure. And this is CH. So if this is my main functional group, then this should be what? This should be my alpha carbon. Correct? Now if this is my alpha carbon, so how this carbon will look like? See, this is CHO. Correct? This is my double bond. Right? And this is what? This compound look like this. Anj. Can you see beta?
Yes, sir.
So can you find any alpha hydrogen to this carbon? Can you see any hydrogen atom is there? You can count the valency. 1, 2, 3, 4. So there is no alpha hydrogen atom attached to this carbon. So this benzaldehyde will not go aldol condensation reaction. Similarly, this aromatic ketone will also not undergo aldol condensation. Will it go aldol condensation? 3 degree aldehyde?
No, sir.
This will also not go, because since this is my main functional group and this is alpha carbon, so you see this alpha carbon does not have any attached alpha hydrogen atom, so this compound will not undergo Aldol condensation reaction. Understood? So these are the limitations. Yes. Now on coming to this compound, this one, formaldehyde. So formaldehyde, it may undergo and it may not undergo the Aldol condensation reaction. It depends upon the certain conditions. Right? Understood?
Yes.
Now on coming to the ketone. So far we were discussing about the aldehydes. Now let's discuss about ketones. So if I take any ketone like this way, in this way, right? And let's draw another ketone, same ketone. This is what? Acetone. Or you can also say this is nothing but proctone. Correct? Correct, beta? Now let's take another molecule of acetone and let's see whether these compounds are feasible to combine with each other or not. Right? So this carbon is bonded to this carbon. This carbon. Let me just redraw it. This is my CH3. Okay. So this is my main functional group. Correct? So the carbon which is
one more on the main functional group.
Valency is complete, so there should be no hydrogen atom here, right? Because we are taking ketone, no, so there should be no this thing. So let me just erase this. Now this compound is correct, right?
Yes.
So can you tell me how this molecule will combine? See beta, this is my main functional group. So this will be my alpha carbon. So if this is alpha carbon, all these hydrogen atoms are alpha hydrogen atom, right? So straight away this alpha hydrogen will combine with this oxygen, right? How they will combine? In the presence of what? Dilute alkali. NaOH. This reagent is very important. If you are writing about Aldol condensation, you have to write this reagent. Right, beta? CH3. Then this is also CH3. This will become OH, and this carbon and this carbon will combine with each other. Understood? Understood, beta? Can you name this compound?
Beta hydroxy.
Correct. So this is main functional group. This is alpha carbon. This is beta carbon. So the name of this compound is beta hydroxy
Methyl butane. Methyl group also attached to the beta carbon. So beta hydroxy, beta methyl.
Actually,
butane.
Yes. So if we are doing this nomenclature, we have to give the numbers also, no? So in place of alpha beta, let's do the numbering 1, 2, 3, 4. We have selected largest chain. So if you'll see, actually this is not longest chain. Longest chain will be like this: 1, 2, 3, 4, 5. Now this is longest chain, right? Starting from here. So this will be 4 hydroxy, 4 methyl, 4 methyl, pentane, 2. Right? Again, if you will heat this compound, if you are heating this compound in dilute HCl, what will happen? There will be loss of one water molecule, like this. And what will happen? There will be a double bond. Understood?
Yes.
If you want to do the nomenclature, you can again do the nomenclature. You have to select the largest chain and then you have to do the reaction. Understood?
Yes.
So this was all about aldol condensation. This is very important, right? As far as the board exams are concerned. Now let us move to the next topic.
Aldol, and in the last reaction there was combination of your alcohol and ketone. So what will be the name of this compound?
Okay. So these compounds, since ketones are combining, right? Since ketones are combining, so this compound is known as actually this is a part of aldol condensation only. So this compound, all the compounds which are beta hydroxy and there is carbonyl group, whether it be ketone or aldehyde, all these compounds are like they fall in the category of aldols only, right? So if you'll see, this logic is not valid here. If you are saying that okay sir, I'll use, because since this is not aldehyde, this is ketone, you will use KET word, Ket also, this is not given in your book, right? All these reactions, whether it be aldehyde or ketone, follows under this category, right? So this is also an aldol, example of typical aldol, right? But this is formed by the condensation of two molecules of ketones. Understood? Good. So will you able to do the nomenclature of this compound? This is easy. You can try in your homework problem, right? So if you are not able to do this, I'll help you to do the nomenclature, right? You have to give the main priority to this this function group, right? You can you have to choose this longest chain, so you will be start counting from in this way, in this manner, right? And then you can do the nomenclature part, right? Now let us
Aldol combine to form a new compound.
not actually two aldols, because aldol is the end product. So what will happen, if you see in previous classes, if you see this in previous classes, in aldol condensation there was combination of same molecule,
Okay,
right?
so then one aldehyde and one
Now
so one
yes,
aldehyde and one ketone will combine to form an aldol.
yes, it is obvious that maybe an aldehyde or ketone is combining, or maybe the same reaction, that is aldehydes are combining, but two different molecules of aldehydes are combining. Two different molecules of aldehyde means, if let's suppose you are taking one compound as the ethanol, then one compound may be propanol. So let's take example of this. So if you are taking a compound like this, so you know this is a famous compound. What is the name of this compound? I'm writing CHO. So what is this? This is propanol, correct? Correct? So I'm drawing this propanol in this way. This is our propanol, correct? Now let us take ethanol. So this is CHOH, right? This is alpha carbon. So there are alpha hydrogen associated to this alpha carbon. Now what will happen? This alpha carbon of this ethanol, this is ethanol, this is propanol. See, the reagent is very important. All these things will happen when you will use this compound, dilute and merge. Otherwise this reaction, you require this reagent in order to initiate this reaction, right? So what will happen? This alpha hydrogen will combine with oxygen of this carbonyl group, propanol compound. Then what will happen? You will get a new compound in like this. So this O will become OH. There is one hydrogen atom. This carbon and carbon will get combined in this way. Understood? Understood, beta?
Yes, sir. Yes.
See, this compound is also, if you see, this is my, when you will understand this reaction, aldol condensation, whether it be cross aldol or whether it be normal aldol condensation, what you will see there is always formation of compound containing beta hydroxy group. If this is my alpha carbon, sorry, this is not this main functional group, this carbon is alpha carbon, this is beta carbon. So you will see here also you are getting beta hydroxy kind of compound. Beta hydroxy, this hydroxyl group is also, and this main functional group is there. So this is what beta hydroxy aldol, beta hydroxy aldehyde compound. Like this is also example of aldol. You can do the nomenclature on your own, right? You have to start from this because you have to give priority to this this function group CHO, right? If you wish, I can write the name 3-hydroxypentanone. This will be the name of this compound. Now again, actually this compound can combine in two ways. I have taken propanol and ethanol. Now what will happen? It may happen that alpha hydrogen of this propanol is getting combined with carbonyl group of this ethanol, reverse manner. So let us take ethanol in this way. Ethanol, this is ethanol plus compound like this. Now the alpha carbon of this propanol will combine with oxygen of this ethanol. So this is also one way, theoretical way of having reaction like this, aldol condensation. Now which product should be more? If there are two ways in chemistry in order to get a compound, then there is a thing which is known as major product and minor product. So which should be your major product and which should be your minor product? Let me just write this, complete this reaction. So you will get like this, then in this way, and then CH2 CHO 1 2 3 4 5, same number of carbon atom. So you are getting same compound or different compound?
Different compound.
How?
Sir, in the first compound it is 3-hydroxypentanol, and in the second compound the hydroxy so it is 4-hydroxypentanol.
Okay, so which should be major product and which should be minor product? Whether this reaction is possible?
Sir, I think second one should be the major product.
Beta, see, what we will get, we usually get what type of compound? We usually get beta hydroxy kind of compound. So if you'll see, this is a beta carbon. This is, see, this is main functional group, this is alpha, this is beta, and this is gamma. Gamma. So this is gamma hydroxy something, right? So your major product will be this compound, because in aldol condensation we generally get the compound of having beta hydroxy carbon atom. So this is a product, this will be your major product. Understood? Logic you have understood? That is why I have shown you two combinations, right? So this will be major and this will be minor. Understood? Understood?
Yes,
now let us move to next topic. Now, as discussed, there is a possibility in cross aldol condensation, so that one molecule of aldehyde and one molecule of ketone may combine. So let us take For our understanding, let us take this molecule ethanol. This is example of aldehyde. And let us take another compound. This molecule, we already know this is what beta? This is ketone. This is what? This is protonone. Correct? Acetone. Now according to the concept, this is our functional group. So this carbon is known as alpha carbon. So the hydrogen of this alpha carbon will combine with this oxygen in the presence of dilute NaOH.
Yes.
So what we'll get? We will get reaction like this way, OH, H, and then CH, H, H. So if you'll see, this is my main functional group. This is my main functional group. So which should be your alpha carbon? And which should be your beta carbon?
In the final product.
Yes.
So the alpha carbon will be the center one, and on the left side,
Yes.
the
Alpha, beta.
extreme left one will
So
be.
again, you are getting kind of beta hydroxy kind of compound, right? This is also example of aldol. Why this is aldol? Because it contains both carbonyl group and hydroxyl group. Now if we will heat, so this will again, there will be a loss of water molecule in this way. So you see, in theory you have to write that how this water molecule is getting lost. The alpha hydrogen and beta hydroxyl group both are combining, right? They both are on the same side of carbon, so they will combine and there will be a loss of water molecule. In the presence of dilute hydrochloric acid, you will get compound like this. In this way. Understood? Have you understood? So now, so far we have discussed about the reaction which is known as Aldol condensation reaction. So what was the limitation in Aldol condensation reaction? Aldol condensation reaction was possible only with those compounds which have alpha hydrogen atom, which should have at least one alpha hydrogen atom. Now what will happen to those compounds which does not have any alpha hydrogen? What will happen to those compounds? How their condensation will be done? So the answer to this question is Cannizzaro reaction. Right? So Cannizzaro reaction gives the answer to the question. Wherever aldol condensation fails, this Cannizzaro reaction prevails. I'll show you this a very simple example. So what is happening in this case? Let's suppose we are taking a compound like this way. We have already discussed about formaldehyde. So let us take compound like this. This is our formaldehyde. Correct? Formaldehyde. Now let us take another molecule of formaldehyde in this way. And let us take what? Concentrated. In previous case, we were taking dilute NaOH. Now we are taking concentrated alkali. So what will happen? Again, this hydrogen atom will combine with this one. But now what will happen? What will happen, beta? Any idea what will happen? Okay, so there are beta two compounds. So unlike this, what has happened when we are using concentrated NaOH solution? So what is happening? There is a oxidation reaction which is going on. How this oxidation reaction will happen? There will be an oxidation reaction. So if you see this this molecule CH3 and this is OH, so this will become methyl alcohol, and one compound you will get as sodium formate. So there will be formation of two compounds. Understood?
Yes, sir.
How this is happening? Because it does not have any alpha hydrogen. If it has like alpha hydrogen, then you should get what? You should get a compound which should contain both alcohol and carbonyl group. But in Cannizzaro reaction, what is happening? We are not taking any of the compound which is having alpha hydrogen. So they cannot go Aldol condensation reaction. So in this reaction, what will happen? There would be a reaction which will be involving simultaneous oxidation and reduction of aldehydes containing no alpha hydrogen atom. So that is why this reaction is known as Cannizzaro reaction. So you can understand this in this way. We have taken two molecules of formaldehyde, and when we have treated this compound in the presence of concentrated alkali, concentrated NOH, what is happening? There is a simultaneous oxidation and reduction reaction. So which reaction, which molecule is getting oxidized and which molecule is getting reduced? Any idea? How this methyl alcohol has formed?
Methyl alcohol has undergone reduction.
See, if you will focus on this compound, yes. So there is, if you will consider this compound, so this compound has undergone what? Reduction. This compound has undergone reduction and you get what? Methyl alcohol. This compound has undergone oxidation.
Yes.
Oxidation of aldehyde gives carboxylic acid. So that is why you are getting a salt of carboxylic acid. So this is a salt of carboxylic acid. That is why you name this compound as sodium formate, because this is what? Formic acid. That is why you call this compound as sodium formate, salt of an acid. Understood? So in Cannizzaro reaction, there is what? Simultaneous oxidation and reduction reactions are happening. Simultaneous.
So it is an example of redox reaction.
Yes, you can, but no, this is not combination of redox reaction, right? Because in redox reaction, one compound is getting oxidized and the other compound is getting reduced. Right?
Yes.
Simultaneous reduction and oxidation reaction. And oxidation. Understood? This is Cannizzaro reaction.
Yes.
Now you can take any aromatic compound also in this way. This is what, beta? This is benzaldehyde. You can take another benzaldehyde. You can take any orientation, because why I'm taking any orientation, beta? Because I'm not bothered whether this hydrogen atom is going to combine with this or not, right? Because I'm not bothered. So what will happen? Simply, if there are two similar molecules in the presence of concentrated NOH, then what will happen? One molecule is going to reduce, one molecule, for one molecule reduction reaction will happen, and for the other molecule oxidation reaction will happen. So if you will do the reduction of this compound, what you will get? You will get a compound like this. See, reduction of CHO is what, beta? If you reduce this compound, any compound, let's suppose you are reducing this compound, reduction. So what will happen? Addition of hydrogen is reduction. So what you are getting? You are getting alcohol, right? Reduction of aldehydes is alcohol. We have already understood this concept in Clemmensen reduction reaction, Wolff-Kishner reduction reaction, normal reduction reaction, in which we are using lithium aluminum hydride, sodium borohydride compounds like this, reducing reagents, right? We have also understood oxidation reaction, in which from aldehydes we are getting what? We are getting carboxylic acid. So in this reaction, what is happening? Since you have understood, you have already studied oxidation and reduction reaction, now this is combination of both, Cannizzaro reaction. So this, on reduction, you will get a compound like this, and on oxidation of this compound, you will get compound like this. If you want to add some, if you want further reaction, this is nothing but, this is salt of what? This is salt of which acid? This is what? This is benzaldehyde, and this is what? This is sodium benzoate. So what should be this compound? This is sodium benzoate. And what is this?
Benzoic acid.
Correct. Benzoic acid. This is benzoic acid. Correct? Have you understood this concept?
Yes.
So in theory, you will be writing about Cannizzaro reaction. This is a simple combination of simultaneous combination of oxidation and reduction reaction in the presence of concentrated alkali, that is NOH. For those compound, this reaction is possible. For the compound which do not have alpha hydrogen atom.
Alpha hydrogen.
If the compound does not have alpha hydrogen carbon, and similar compound like this, if they will combine, they will give a one molecule will get reduction reaction and the other molecule will get oxidation reaction, and you will get one alcohol and other compound will be salt of carboxylic acid. Understood? So what happens in a Tishenko reaction? What is Tishenko reaction? Tishenko reaction is a very similar reaction to that of which reaction we have studied in the previous case? We have studied Cannizzaro reaction. Cannizzaro reaction. Right? So I have discussed only one case of Cannizzaro reaction. There is cross Cannizzaro reaction also is there. Right, beta? So what will happen in cross Cannizzaro reaction? The process is similar, but this reaction will be in different compounds. Right? But that compound should not.
Number of carbon atoms?
Yes, compound containing different number of carbon atom, but they should not have alpha hydrogen atom in them. Right? So there will be a cross Cannizzaro reaction also possible. Cross Cannizzaro reaction is also possible. Between same molecule, it is Cannizzaro reaction between different molecules, but not having this alpha hydrogen atom, that will be termed as cross Cannizzaro reaction. This is I guess this is understood, easily understood. Right? Example of cross Cannizzaro reaction, you can take one molecule of this formaldehyde and you can take another molecule, this benzaldehyde. So these two molecules are different, but they are having no alpha hydrogen carbon atom. So on the combination, what will happen? What will happen, beta? What will happen? Okay, now there, yes. In cross Cannizzaro reaction, there are two possibilities. Since you have two molecules, two different molecules. Now, what we have studied that out of two molecules, one molecule will undergo oxidation reaction and the other molecule will go reduction reaction. So, how you will come to know that which of the two molecules will go oxidation or reduction? How you will decide? How? See, if you now to answer this question, the answer to this question is very simple. The bigger molecule will undergo reduction reaction and the smaller molecule will undergo oxidation reaction. So this you have to keep in mind when you are doing this cross Cannizzaro reaction. Understood? Understood?
So
the bigger molecule means this benzaldehyde will undergo reduction. So you will get a compound like this, alcohol, and this compound will undergo oxidation. So you will get what? Sodium format. Understood? So you can, if you combine this, you will get cross Cannizzaro. I am giving this to you. So now let us know what is Tishenko reaction. So Tishenko reaction is similar to Cannizzaro reaction. We are going to take two molecules which does not have any alpha hydrogen carbon. So this what will happen in Tishenko reaction? In Tishenko reaction, this actually I'll tell you this Tishenko reaction. This is possible for all the cases, whether the carbon contains alpha hydrogen or not. So Tishenko reaction, if you see, I'm going to write this is valid for both alpha hydrogen present or not present. Understood, beta? So this is a modified form of this Cannizzaro reaction. So this reaction is possible for both the cases, whether there is alpha hydrogen atom is there or not present. Right, beta? So Tishenko reaction will happen in both the cases. What is special about this reaction? The special about this reaction is, let's suppose we are taking a molecule which have this alpha hydrogen atom. So let us take ethanol for our case. We are taking ethanol in this way, ethanol. Now this reaction happens in the presence of what? Which compound? In the presence of ammonium methoxide. Ammonium methoxides look in this way. It look like this. This is ammonium methoxide. So what will happen? In the presence of this ammonium methoxide, there would be what? There would be formation of two molecules of alcohol. There would be formation of two molecules of alcohol. So let me just draw this. So this is what? This is our ethanol. So this ethanol will become ethanol. Correct? And the other compound will also undergo reduction, and what you will get directly?
Another molecule of alcohol.
So one molecule is going reduction, complete reduction, right? And the other molecule will undergo oxidation, and you will get compound like this.
Carboxylic acid.
Yes. So one is acetic acid and the other is alcohol. Understood? So this is Tishenko reaction.
Yes.
Right, beta? So this is valid for both the cases. This is a simple example. You can understood this thing with a simple example. Understood, beta?
Okay, sir. Yes, sir.
Right? What is Schiff test? Schiff test is nothing but this is test which is given to the name of the reagent, which is known as Schiff's reagent. So what is Schiff reagent? Schiff reagent is nothing but this is what? Dilute solution of a dye. This is a dilute solution of a dye. Dilute solution of a dye. Sorry. So what is a dye? So which dye? We are talking about this dye. Rosen hydrochloride. So what is the special about this reagent? What is special of this about this reaction is nothing but if you'll take any aldehyde and add this reagent, Schiff reagent. Schiff reagent means rosanilene hydrochloride. So add Schiff reagent to this compound. So what will happen? This will give you a pink color. So if you notice a pink color by adding Schiff reagent to an unknown compound, so this gives a confirmatory test that this compound contains an carbonyl group which is known as aldehyde. Understood, beta? So this this test is only applicable for aldehydes. Only applicable for aldehydes. This reaction is not applicable for only applicable for aldehyde, not applicable for ketones. Understood? Understood, beta? Ketones will give negative result.
Okay.
So only this much is important. Details of this test is not important. Right?
Sir, so what will be the final compound or reaction or result of this reaction?
There would be a formation of salt. There would be a formation of salt, and because of the formation of salt, you are getting pink color. Right?
Okay, sir.
Okay. So now let us move to next concept. Now let us understand what is Perkin's reaction. So Perkin reaction is nothing but this is a reaction of aromatic aldehyde with aliphatic acid. Aliphatic acid anhydride. So what you will get when you will combine this aromatic aldehyde with an aliphatic acid anhydride, you will get a compound of this form, alpha beta unsaturated acids. Unsaturated acids. So I guess this much theory is sufficient to write in the exam. So aromatic aldehyde, this is a combination of aromatic aldehyde with an aliphatic acid anhydride to get the alpha beta unsaturated acids. So you can understand this with a simple example. Let's suppose I am taking aromatic aldehyde. The best example of aromatic aldehyde would be benzaldehyde, right? And now let us take a compound which is known as anhydride. So what happens in an anhydride? What is there in anhydride? This is CH3, C double bond. Anhydride is compound like this, acid anhydride. This is an acid anhydride. If you will see, this is nothing but this is acetic acid. So this is combination of two molecules of acetic acids. This is acetic anhydride. Acetic anhydride. Now what will happen? There would be a loss of water. And in the presence of what? In the presence of which compound beta?
Aluminium. Aluminium. Oxide.
Let us write. In the presence of this thing, acetic acid. So we'll get a compound like this beta. You can do the combination. So this carbon and this carbon will get combined and you get a compound like this. Alpha beta unsaturated acid. Why unsaturated? Because there will be a double bond in the compound, right? So only this much is important in Perkin reaction. The rest things are not important as far as your board exams are concerned, right? So you can complete this reaction on your own, right, beta? So whatever like compound you will get, name this as a alpha beta unsaturated acid. That's it. Since we are using sodium acetate, so there would be formation of this compound, so there will be formation of water plus acetic acid plus this compound. So this compound will be known as alpha beta unsaturated acids. So only this much is important. You can combine these molecules. They will be followed by loss of water. So carbon and carbon, there will be double bond carbon, right? Understood?
Yes.
Have you understood? So actually what will happen, see this compound will will get combined this much, right? Understood?
Yes. Yes.
This is the significance of Perkin's reaction. So if let me just complete this reaction so that there is no confusion in your mind, right? So if I'll combine, I'll get a compound like this. See, this will be our compound. Correct, beta? Our compound will look like this. In this way.
Yes.
This is our compound. Now what will happen? Again, treat it with water. So what will happen? You will left with this compound. This one. There will be formation of acetic acid. Day is only one. COOH, CH3, COH, CH3. This is acetic acid. And this compound is known what beta? This is alpha beta unsaturated acid. This is alpha comma beta This is unsaturated acid. This is also known as cinnamic acid. Very important. Cinnamic acid. So this is all about Perkin's reaction. Have you understood?
Yes, sir.
Understood? Good.
Yes, sir.
Good.